Hi and welcome again. So in this video, we're gonna learn functions. So what are functions? Just like how I mentioned in the first video, functions are just like the mathematical functions. So what is a function in mathematics? Well, basically a function in mathematics is just some application that takes input and produces output. Say for example the sine function, So the sine function basically takes a number, say 0 for example, and then it produces a result. So sine of 0 is 0, sine of pi is 0, sine of pi over 2 is 1, sine of pi over 4 is 1 over square root of 2, and so on. So it takes a number and it generates another number. That's a function in math. A function in math could take more than a number. Say for example, I don't know, like the max of 2 and 3. Now the max of 2 and 3 will take 2 and 3 and will return 3 because 3 is bigger than 2. There's also the min function. So the min function will take 2 and 3 and will return 2 because 2 is less than 3. And so on. So a function could take one or more input and return one single output. The output could be an integer, it could be a number, it could be a real number, it could be a text, it could be a string, it could be anything basically, but it's just one single output. So that's a function in math. It's the exact same thing in computer sciences, in programming. In programming, a function is something that takes input and produces output. So there are basically a bunch of functions that are already available by the system that we can use, already created by other programmers, the ones who created the C language. But we can also create our own functions. And I'm going to talk in a bit why would anyone want to create a function. Okay? So this printf, for example, is a function. It takes input and it does nothing. It does something, but it returns nothing. Okay? It has no result. You just take input and it does some stuff. It invokes some system calls in order to print the content here on the screen and so on, and it returns nothing. Okay? So there are basically a lot of other functions. So let's test whether let's get rid of that from the previous video. So for example, if I, for example, type in the min of, say for example, 4 and 5, and then try to build that code, it tells me that there is no min function already there. Okay? So why don't we just create a min function, a function that takes two integers and then returns the one that has the less value. Okay? So in order to create a function, the first thing we need to type is the type of the function, the type of the value that the function will return, and then the name of the function, and then a parentheses, and then the list of parameters, so the type, and then the name of the first parameter, and then the type, and then the name of the second parameter, and so on and so forth. If you have more variables, more parameters, you just put them there like that, the type and then the name, then comma, then the type and then the name, and then comma, and so on. And then you have an opening and closing curly braces. Now the opening and closing curly braces basically contain all the needed instructions, all the instructions that this function will execute before getting into the result that it will return. Okay? So basically, I'm going to create a variable called m, which will contain the result, and I will put inside that m a. So I'm going to take a and copy it over on m. And then if b is less than m, then basically I'm going to update m, so m will take b, okay? And then finally, I'm going to return the value m, okay? So we take m, we copy its content into m, and then if b is less than m, then b is the minimum, right? So we update m with the value of b, and finally we return m. Now we are sure that m contains the value, the minimum, okay? It contains the minimum between a and b. Now let's try to run that. And as you can see, now the min function returns 4. So int a takes min of 4, 5. Now the system knows min because we have defined the function here, okay? So if I say min of 4 comma 5, the 4 will be, the a will be replaced with the 4, the first parameter, and the b will be replaced with the 5, the second parameter. And notice that they are in order, okay? So the first one stands for a, the second one stands for b. Of course, there are a bunch of ways to define this function. You can, for example, say if for example, if a is less than b, then we just return a. Otherwise, else we return b, okay? So if I try to compile and run this, it will produce the exact same result, 4. Now, I can also just write this instruction in one line of code. So it will be, for example, return something. What is that thing? Return a is less than b. Question and mark, a colon b. We have, I have explained this earlier, but just let's mind refresher here. So this is a Boolean or a logical expression. So this one will return either true or false. So if it is true, a is less than b, then we're going to return a. Otherwise, we're going to return b. So this whole expression will be replaced with a if this is true, or b if this is false. So in reality, we'll return an a or we'll return a b, okay? Depending on the condition here, depending on the logical expression. And we finally get that minimum. We put it in this other variable a, and then we print that other variable a. And of course, to call a function, all you have to do is to type in the name of the function and then give it a parameters, just as I explained earlier. Now, a function could also be a function without a return value. For example, let's create a function that prints hello. So void hello. It takes no parameter, and it basically printf hello. Okay? That's our basic function. And let's remove these two instructions from here. And let's remove that min function from there. So here we're creating a function called hello. It takes no parameter. And when that function is called, it will execute this instruction. And that's it. Now here we put void because the function does not return any value. We don't expect it to return anything. All we care about that it prints something and that's it. We don't need any return number or whatever, okay? And that's why we use void. Void means no type, meaning that maybe it's procedure, okay? It has no return type. It has no return value, just void, nothing. It's okay. In fact, in the C programming language, you can just get rid of the type there, so it'll be automatically void. So you just put in the name of the function and that's it. Okay. Now, in order to call the function, just type in its name, give the list of parameters, and that's it. And as you can see, it calls the function hello. But I do not recommend not put in a type there. Always, if your function does not return anything, just put in void there. Because, well, in C this is okay. But in C++ later, if you want to move to C++, if you don't use a type here, if you don't put this void, it will generate an error. So it'll be a good practice if you train yourself to always put it there. And then you can still use the return instruction, but as you can see, when you use void here, you don't put any value in front here after the return. Okay, you don't like say return 5 or 4 or whatever, just return. Okay, meaning that, okay, we've done executing parts of this function, we want to quit. Return means quit. Okay, that's it. Now let's create the most simple and basic function. That function will be, I'm gonna call it ret5, for example, because it's a function that returns the number 5. So this function basically returns 5, and 5 is of type integer. So I can printf an integer So I can print that ret5 function, and that ret5 function will return the number 5. So this function will be replaced by its value, which is 5, and it will be sent to the printf function, so we have 5 there. So basically that's the notion of functions. That's the notion of functions. Now, why do we use function? I mean, can't we just like not use functions? Like if a function is just a code that if function is just something that I call it and it gets executing a bunch of instructions and then I get back to the main function here, can't we just put everything from this function inside the main function? Like, can't we just get rid of this function thing that we've been using? Well, yeah, we can. Of course we can. But that is a very bad and terrible idea. Why? Well, basically, functions have come because they are a great way to simplify the code. Simplify the code and make it a modular code, meaning a bunch of components that are separate and that you can work in every one individually. So if you have a program, a very complicated program, you can just divide that program into a bunch of smaller functions and then build every function individually and then make sure that every one of them work, and then just combine the functions together in order to get the final result. If you try to make everything just in one block, chances that if you make one mistake, it will affect the entire code, okay? It might affect hundreds or even thousands of lines of code, and you won't tell where the problem is. But if you like decompose your program into smaller functions, and then you test every function individually. Okay, this function works. Okay, so the problem is not related to this function. Let's test the other function. The other function works, so the problem is not related to the other functions, and so on and so forth, until you find where the problem is and you solve it. So actually, this procedure simplifies the development process very, very much. Okay, so that's why whenever you encounter a problem in computer sciences or in programming, we really encourage you to use functions. In fact, this is a very, very popular theory. It's the theory of the theory of Pandora's box. Okay, I'm sure people who played God of War knows what I'm talking about. So it's the theory of Pandora's box. The theory of Pandora's box meaning that you just encapsulate your work. It means that you just think of a problem and then you design a solution for that problem, and then once you're happy about your solution, you don't think about that solution nor that problem anymore. Okay, just create a solution that works pretty perfect, and then you forget about all the details. It just works, okay? Let's say, for example, I've created a function here. It's a function that calculate, I don't know, the factorial, okay? And I give it a number n so that it calculates the factorial. Now let's say that this function will do a bunch of stuff that are pretty complicated, okay? We just think about this function once, only once. And once we are sure that this function works, we just close that little area there and we forget about how it works. All we need to know is how to use it. I mean, think of it in a second. If we think about the printf function, the printf function has like thousands of lines of codes inside it. Just to print something to the screen, it's not pretty easy. It's very complicated. Okay, it's system calls and stuff like that, and maybe dealing with registers and then the terminal and then the console. It's really complicated. But yet you can do it just in a single line of code. If it was not thanks to functions, you wouldn't be able to do that. So you make a lot of hard work and then you just encapsulate them. You put them inside a box, a Pandora's box, and you define how to talk to that box without ever looking at what is inside that box. You don't care. It just works. We don't care how it works. Okay, it does the job. The same theory is applied in like electronics, like when you buy an integrated circuit. Those small circuits, like, let me just show you a picture here. Integrated circuits. Let's see. So these integrated circuits, okay? These integrated circuits. These one over here. When you buy a couple of these and you'd like to build a couple of projects with them, some electronic projects, you don't care how they work, okay? All you care about, what is the meaning, what is the significance of all of these pins, pin 1, 2, 3, 4, and so on, what they do, how to connect to them, and how to deal with them. That's all you care about. We don't care about how this whole thing got implemented. And this adds a layer of simplicity to solve the problem. The same idea in computer sciences, okay? So, for example, the developers of operating systems, they don't really know how the CPU works internally, okay? All they know is that how to deal with that CPU, how to connect with it, how to talk to it, okay? And the makers of the CPU do not also know how the transistors work from the inside, and the builders of transistors from the inside do not really know how electrons and quantum physics work. They don't care, okay? The same thing, the developer of a website do not care how the Apache server works. He knows just how to create and how to build a website. That's all he cares about. Okay, he doesn't care about all the internal parsers and everything. We don't care, okay? He does not care. The developer of Android application, he doesn't care about, or iOS or whatever, they do not care about what is happening inside those libraries that they're using. It's just a Pandora's box. You don't need to know a lot of details about something. All you have to do is how to deal with that. The same thing in your life. You don't know how a car works, but you know how to drive it. You don't need to know how the engines works from the inside on all that details. Okay, so if you just get into your car and find all the wires and everything, grab the whole place, then you wouldn't be able to drive that car, right? But they've hidden all of that details. They just showed you a wheel and a counter and a gear and so on, and taught you how to drive, and then you'll be able to drive. The same thing. I just showed you how to deal with the printf function, what to give it, what not to give it, what it will do for you, and voila, you're up and running and know how to deal with the printf functions. So I hope that this shows the importance of functions and why you have to use functions whenever possible.